You may find some old systems that have installed the quick vent improperly. Notice that the force of the condensate being slammed into the end of the pipe moves water up into the vent, thus preventing the vent from working. The only way to correct this situation, or prevent it from occurring in a replacement system, is to move the quick vent back at least 15 inches. Coming off of the main are the individual risers to the radiators. Notice that the T from the main is installed with the outlet looking up at approximately 45 degrees. Into this is added a short nipple with a 45-degree elbow installed, creating a swing joint and accommodating the run to the radiator riser. The proper pitch for this run is also at least 1 inch per 20 feet. In addition, approximately 3 feet of piping are used to connect the radiator riser to the main. This allows sufficient room for the steam and condensate to pass by each other. Upon inspecting the radiators, we notice that the legs should sit squarely on the floor and are slightly pitched from the air vent end back towards the radiator riser. This allows for the flow of condensate back to the main. The riser is connected to the radiator through a supply valve. On this one-pipe steam system, the valve must be fully open to allow the proper flow of steam and condensate. At the other end of the radiator is the radiator air vent, which vents the air from the radiator, closing when the steam enters the vent, thus keeping the steam in the radiator. It reopens when the steam is no longer present and the temperature drops. It is highly recommended that all radiator vent valves be replaced at the time of a new boiler installation and at regular service intervals to assure highest efficiency and comfort. You may find an adjustable air vent on some radiators. They appear similar to the other air vents, except the cap has several adjustable settings. This allows you to adjust the speed at which the air escapes from the radiator, thus affecting the rate at which the radiator heats. These adjustable air vents are used for balancing a system. In other words, normally the radiator closest to the boiler will heat first, and the radiator farthest away will heat sometime later. By using an adjustable air vent valve, you can vent the air slower from the closer radiator and faster from the farther radiator, thus heating both radiators approximately the same time, resulting in a more balanced heating system. Upon further examination of this basic one-pipe steam system, we should notice that the condensate from the steam must return through the same pipes used by the steam flowing to the radiators. We also should notice that the steam and condensate are traveling in the same direction along the main. At the end of the main is a connection into a dry return, which then connects into a wet return, and finally into the Hartford loop. The dry return is that portion of the return main located above the boiler water level. And the wet return is that portion of the return main located below the boiler water level. The wet return is always completely filled with water, providing a water seal, and does not carry air or steam as does the dry return. This completes our basic one-pipe steam system circuit. However, there is one very important dimension we must be aware of in order to properly get the condensate back into the boiler. This is known as dimension A, which refers to the pressure drop of the system, static head of the system, and a safety factor. As the steam travels through the system, it loses some of its pressure. So by the time it reaches the return piping, It has less pressure than the pressure on the water inside the boiler. Since the pressure in the return is less than in the boiler, the water in the return rises up. It could rise up into the main, creating all kinds of problems. We won't go into the mathematical equation for calculating dimension A. However, it is important to remember that typically for the proper condensate return of a steam system under 100,000 BTUs, you should have a minimum of 18 inches from the vertical drop of the dry return to the boiler water line. On steam systems over 100,000 BTUs, dimension A should typically be not less than 28 inches. On any steam boiler replacement using this piping arrangement, dimension A should always be checked. Before we examine some other typical steam boiler system piping configurations, let's take a moment to review the material just presented. Turn the videotape off now and review section D in your workbook. With this understanding of a basic one-pipe steam boiler system, let's take a look at some other typical steam piping systems. The system we've been using as our example is known as a one-pipe parallel flow. Here, the steam and the condensate flow in the same direction in the supply and return main. For all one-pipe parallel flow piping systems, dimension A must be sufficient to provide for the gravity return of the condensate and to help prevent the system main from flooding. The system could look like this, dropping from the main immediately into a wet return. Or like this, with a dry return that eventually drops to the wet return. This system is known as a one-pipe counterflow. The condensate flowing in the opposite direction of the steam. This system requires the main to be pitched upwards, away from the boiler, at least 1 inch per 10 feet, or twice the pitch of the one-pipe parallel flow system. Since the main in a one-pipe counterflow system handles both steam and condensate flowing in opposite directions, the main pipe size must be larger as compared to a one-pipe parallel flow system. Two-pipe systems have the steam and condensate carried in separate lines. The steam flows to the radiator via the main and branches. The condensate is then carried back to the boiler by a separate return line. Two-pipe systems use traps at the end of the radiator and supply main to prevent steam from entering the return piping. A thermostatic trap at the end of the radiator discharges air and condensate from the radiator. Therefore, an air vent would not be used for this type of system. Since some condensate does form in the steam supply main, the need to remove this condensate is important to allow the efficient flow of steam through the system. Since thermostatic traps normally wait for the condensate to cool slightly before opening, a float and thermostatic F&T trap is installed at the end of the supply main, at its connection to the dry return. F&T traps are fast-acting traps that allow both air and condensate to be discharged from the system main. Modern steam boilers are designed to be much more energy efficient than older boilers that you might find on a service or installation call. These new boilers are usually smaller, maybe only a third the size of older units. Thus, the newer units hold less water. These newer boilers are designed to steam at full capacity for 10 to 15 minutes before the low water cutoff shuts them off. Many steam systems are able to return the condensate to the boiler during this 10 to 15 minute cycle time. However, some steam systems, because of building size and shape, sagging pipes, or sludge in the piping, may require 30 minutes or more for the condensate to return. For residential systems, if the condensate return is too slow, this may cause a low water cutoff to cycle off too quickly due to insufficient water being returned to the boiler. Now this most likely means there's a problem, such as an obstruction somewhere within the system piping. It's recommended that you check the system and correct the problem. It is never a good idea to use a water feeder to increase steaming time. On these installations, fresh makeup water is introduced into the system every time the water feeder is activated. The accumulation of this makeup water will gradually flood the boiler and require frequent manual draining of the boiler to restore the proper water level. On some installations, a reservoir pipe may be used. The reservoir pipe, located here, provides additional water for the boiler. That will increase steaming time before the water level drops in the boiler to activate the low water cutoff to shut off the boiler. A reservoir pipe may be all that is needed to increase the steaming time for proper boiler operation. Consult manufacturer's instructions for proper reservoir pipe sizing and placement. On some semi-commercial installations, the use of a boiler with a condensate tank, feed pump, and a low water cutoff and pump control might be used. The receiver tank consists of a reservoir with a vent line, water sealed and open to the atmosphere, into which the return line discharges its condensate. When the low water cutoff cycles off on low operating water, the condensate discharges from the receiver into the boiler until the low water cutoff is satisfied that it has a safe boiler water operating level. The addition of a mechanical condensate return system can be rather expensive and not generally used for a typical residential steam boiler installation. During the last few minutes, we examined a basic one-pipe steam system, its components, plus examples of other common steam systems. Let's take a break now and review this material in your workbook. Remember, if there's any material you aren't sure of, just rewind the videotape and review the section again. Turn the videotape off now and complete section E in your workbook. In this section, we will discuss skimming of steam boilers, either for new installations, replacements, or for regular maintenance. I've been told by experts in the steam heating business that on a great many of their service calls, the problem is solved by simply surface skimming and flushing the boiler. Every boiler must be periodically serviced to assure optimum efficiency and satisfactory operation. Of particular concern is sludge or sediment buildup in the boiler. Because of the age of many heating systems, oxidation buildup can occur in the piping and heat distribution units. The replacement of piping and radiators will loosen this material. Eventually, it will come back to the boiler, the low point in the system. Also, normal operation can loosen some of the material which will return to the boiler as sludge or sediment. Therefore, Weil McLain recommends periodic skimming of the boiler. It's also important that new or replacement steam boilers be properly cleaned before startup. New higher efficiency steam boilers generate steam faster and more effectively. Now, this can cause sludge, rust, and other deposits to be returned from the old system piping to the boiler. Improper cleaning or failure to clean the boiler can result in erratic operation, unsteady water level, loss of efficiency, and even permanent damage. Boiler water does not have to be crystal clear for proper operation and steaming. However, The surface of the water must be free of any flotation material, such as oil, grease, or other foreign matter. Petroleum-based lubricants and pipe joint compounds are used in the manufacturing and installation of pipes, fittings, and control components. Now, some of this material could get inside the system. It can then collect on the surface of the water in the boiler when the unit is heated. Now, often, these materials have high evaporation temperatures that normal steaming will not eliminate. Small amounts of these substances on the water surface in a steam boiler can cause foaming, surging, overheating of the boiler, and insufficient steaming, as well as eventual damage to strainers, traps, and vents. Notice on this Weil McLain Model 76 steam boiler that has been especially modified for training purposes, what 1/4 cup of vegetable oil added to the water does. Draining the boiler will not solve the problem. When the water is drained, surface tension will draw the oil film to the sides of the section walls. The oil will coat the sections, but it will not drain. And this is similar to dirt on a bathtub ring. Refilling the boiler will only cause the oil to float to the surface again. The only recommended way to properly clean a new boiler installation or perform periodic cleaning of an existing steam boiler is by surface skimming, followed by a complete flushing. All Weil McLain steam boilers have a tapping just above the water line for surface skimming. The following procedure is recommended for surface skimming of steam boilers. Now, to begin, install the full-size nipple into the skim tapping. This will avoid spillage on the boiler. Provide some method for running the water from the skim tapping nipple to a convenient floor drain. Adjust the water line to the midpoint of the skim piping. Now, this gives you the largest area for skimming foreign matter from the surface. If you fill the boiler less than halfway up the skim tapping, the skimming process will take much longer and will be ineffective. If you raise the water completely above the skim tapping, none of the surface water and contaminants will escape. In effect, you're coating the upper portion of the boiler with all the surface materials. As you can see, it's important to maintain the correct skim water line. One suggestion is to use a T at the end of the nipple to observe the water line, as we're doing here. If you use this arrangement, always use proper procedures as you would in working with any hot water or steam. Boiling water and steam may splash out and cause severe burns. Often, you can use the water column gauge glass as an additional reference point. Fire the boiler to maintain a temperature just below the steaming rate during the skimming process, typically about 180 to 200 degrees. Now, this allows for optimum flow of surface oils out of the skim tapping. Feed water to the boiler and maintain the proper skimming water level. Cycle the burners off and on to maintain water temperature and to prevent steaming. Now, you should be able to observe if the water is too hot if you start seeing steam coming from the skim piping. Continue skimming until the drain water runs clear. This may take several hours, depending on the boiler size, extent of new piping, and contaminants. While the boiler is still warm but not hot, use the drain cock to drain the boiler completely, flushing out any residual foreign material. Now, this flushing action should help to remove any remaining sludge from inside the boiler. Remove the skim piping and plug the tapping. Close the drain cock. Fill the boiler with fresh water to the water line and start the burners and steam for 15 minutes to eliminate dissolved gases from the makeup water that may be present. Shut the burner off and check traps and air vents for proper operation. Now, in some cases, skimming alone may not completely clean the boiler. If necessary, the boiler can then be soaked with trisodium phosphate or sodium hydroxide, using 1 pound per 50 gallons of water. Or you can use sodium carbonate at 1 pound per 30 gallons of water. Add one of these recommended chemical cleaners to the boiler until the boiler water has a pH of 7.0 to 8.5. Now, this can be tested using common pH paper, usually available at most drugstores. Add one of the 3 chemicals. Fire the boiler to 180 to 200 degrees. Do not steam. Then shut the boiler off. Allow the solution to soak for 20 to 30 minutes. Then drain and completely flush the boiler and refill. Continue flushing until the pH of the boiler water equals the pH of the household tap water. Under no circumstances should the boiler be allowed to steam with chemical compounds inside. If steaming does occur, residuals will be carried out to the system with the steam. Then the system will start to be cleaned and you'll be forced with cleaning the residue that will continue to return to the boiler. Now remember, chemicals should be used in the boiler only as a last resort. For cleaning cast iron boilers, no other chemicals other than these are recommended. And that's it. You've just learned one of the most important steps for the proper, efficient operation of a steam boiler. Now remember, when quoting a job, either for installation or for service problem, to include the time it will take to skim and flush the boiler. Now it's time to complete the workbook review for Section F. You'll find it goes quickly. When you finish the section review, be sure to complete the final evaluation located in the pocket in the back of the workbook and return it to Weil McLain. We'll evaluate it and send you a certificate upon successful completion of this Weil McLain heat program on steam boiler operations. Now before I go, we at Weil McLain want to congratulate you. In just the time you've taken to invest in this course, you've become a more knowledgeable steam heating professional.